Thank you very much for that generous introduction. This is truly a great honor for me to be giving this Tyler Laureate lecture. There are many, many, many I have to thank, but I'm saving all that for tomorrow, the awards dinner. And normally what I do is that, let's say 2 months from now, you're going to forget everything I said or I'll be saying today. But if I want to keep one message, and that's there, so hopefully you'll remember that. The point I want to make is that we have already put enough of these so-called greenhouse gases, pollutants, that are surrounding the planet, and they're in the process of warming the planet. And we have already committed the planet to enough warming to make many threshold level of what I call iconic changes. My distinguished colleague, Professor Ali, would talk about some of those, and I'll describe what others are. What I'm going to do is that this is, as you know, a rather pessimistic conclusion. So I want to walk you through the science which led to that. And also, I have been, I must say, extremely discouraged about my science. Every time I stick an instrument in the air, I come back with one more disaster. So I've been starting to work on solutions. And so hopefully I will have time to touch on that. And the bottom line is, there is a way to get out of this mess. And not that I have the way, I have a way, but there are many ways. So just to get a perspective on the problem, let's look at that image on the left-hand side. That was really taken, I was following on a Gulf aircraft, dust plume and pollution plume from China all the way across the Pacific into the US. Believe me, I did track down many soot particles and black carbon all the way across over San Diego and on to Colorado. But in any case, we had to dodge on that day 2 cyclones, and we did manage to do that. Otherwise, I wouldn't be here. The thing I want to make is that, when we go outside, we look at the atmosphere, it looks vast. You say, we can't do much of it. This is just really huge. It turns out, look at the perspective, it's really a thin, vulnerable layer, extremely thin layer. And it's in this layer we are dumping billions and billions of tons of pollutants. And what is the source of that? Of course, smokestacks, automobiles, biomass burning, agriculture. And that's my grandmother's kitchen. And I have enjoyed some of the best meals in that kitchen. So the question I want to ask is, why should she worry about what car I'm driving here? Likewise, why should we worry about what she's cooking with? Take a close look at the movie next. My grandmother is not no more, but let's just imagine she's there. This movie shows how fast air particles travel across the world. It just takes air 3 to 5 days to go all the way from China across into the US and comes in billions and billions and tons of other things, pollutants they emit. So while the Chinese are giving us their gift, we are passing along our gift to Europeans. Lot less time, just in 2 days, 2 to 3 days. And pollution from Europe goes on to Asia. There are many lessons in this. Every time I look at it, I see something new. See remarkably how in short time biomass burning in South America dives into the Antarctic, into the polar oceans. So the more other message I want to convey is that we are not going to solve this problem by pointing fingers at each other. This is a problem we have collectively created, and we've got to solve it collectively. And so that's the issue I want to touch on. So we have surrounded the planet with these gases. So why should we worry about this blanket? Imagine on a cold winter night, you put a blanket on you. It keeps you warm. Not because the blanket gives any heat, it just traps the body heat, right? And so prevents the heat from your body escaping. So you're warmer. You're trying to get rid of more heat. That's exactly how the greenhouse gases work. They trap the heat, which would have left the planet. We call it infrared radiation. And so the planet has to get hotter to get rid of the heat, because the planet always tries to maintain what we call an energy balance between what's coming in and going out. So that, in a nutshell, is this whole thing about why we are worried about greenhouse gases. It's well-known physics, quantum mechanically, we have measured all the absorption characteristics, etc. So the most deadly of these greenhouse gases is carbon dioxide. Why is that? Anything we burn, any combustion, ultimate byproduct is carbon dioxide. The fuel is carbon and hydrogen molecules stuck together, so the carbon becomes CO2. Okay? We used to think until the 1970s, carbon dioxide is the only greenhouse gas we have to worry about. Then I was new to that field. I was a postdoc in an obscure institution looking at reentry physics. And I chanced on this famous paper by Rowland and Molina, where they talked about chlorofluorocarbons, releases the chlorine and will attack ozone layer. And then in graduate school, I had learned any polyatomic molecule has tremendous vibrational degrees of freedom when it absorbs and emits radiation. So I started to look at the greenhouse effect. I was shocked to find adding just one molecule of CFC has the same heating effect as 10,000 molecules of carbon dioxide. And thank goodness for the work by Molina and Rowland, and then the Antarctic ozone hole, CFCs were banned. Had we not had that discovery, we would be talking about a CFC catastrophe in terms of climate change. I did not realize that till Ralph Cicerone 2 years ago pointed that out. So after the CFC work, a whole host of new gases were discovered, were warming the planet. There was methane, there was nitrous oxide coming from fertilizers, and ozone is another issue I was working on. What we think of ozone here as a pollutant is also a major greenhouse gas. So all that put together, WMO had asked me to chair a panel, and we basically concluded, first of all, the chemistry and climate became strongly linked because of the tropospheric ozone. Okay? So we can't think of the climate system independent of the chemistry. The whole cottage industry of work is going on there. But we basically concluded that the non-carbon dioxide trace gases contribute as much as CO2. And then about 10, 15 years later, the so-called Intergovernmental Panel on Climate Change, I belong to that, and they got their, they were awarded the Peace Prize in 2007. Their report and the earlier reports confirmed our findings that CO2, I'll start to tell you what this unit is, but think of that as thickening of the blanket, okay? Carbon dioxide is thickening the blanket so much, then these other gases and ozone, when you add it all up, it's pretty close to CO2. Look, on the one hand, this is bad news. We thought we had to just deal with CO2, now we have to deal with all these other things. But it's also good news because some of these gases are easier to get rid of than CO2. And somehow that message has gotten lost in the current discussion of how to deal with the problem. And I want to touch on that.